Hi, welcome to the Unit 0.2 Matter and Scientific Skills, Measurements and Unit Notes. This video will go over unit conversion and specifically how to do dimensional analysis to convert to and from units. So before we begin, I want to give you an overview of dimensional analysis. You may have heard of it before, but it's a technique used to convert from one unit to another. And before I go into how it works, I just want to emphasize that it really only works for things that have scalar relationships. And what I mean by scalar relationships is that the units, for example, a kilometer and a meter, you can convert to or from them by simply dividing by 1,000 or multiplying by 1,000. And you can tell things are scalar relationships because when you write out how they are equivalent, so we write that 1 kilometer is equal to 1,000 meters, you'll notice that on either side of the equal sign, you just have one term. Whereas something like this, which is the relationship between Kelvin and degrees Celsius, this is not scalar. In order to convert to and from them, firstly, you can't just multiply and divide simply. You have to actually add or subtract a number. And also you can tell because when you look at the equation that relates them, you have more than one term. You have degrees Celsius and plus 273 on one side of the equal sign. So scalar terms, they're things that are related by just simply multiplying and dividing only. And they don't involve adding or subtracting. Okay, so how does dimensional analysis work? During dimensional analysis, what you're doing is you're multiplying fractions until you cancel out the units you don't want and you keep the units you do want. So the way that the setup works is your first fraction will always be the value that you're given. So you're given, and we usually put it over 1 just to make it a fraction. And then the other fractions are going to come from conversion factors. And they're going to be set up in such a way that you can cancel out the units of your given and eventually get the units of the thing that you want to have in the end, the units of your find. Now these conversion factors are these relationships here. So you know how a fraction has two parts, a numerator and a denominator, and how this equation has two parts. You're going to take the parts of this equation and turn it into a fraction. Those are going to be your conversion factors. So the best way to sort of visualize this is just get right into it. And we're going to do that with these examples. All right, so our first example says, how long is 3.751 times 10 to the 5 millimeters in meters? Now, firstly, I need to think about what I'm trying to convert to and from. So I'm given millimeters, and I want to convert it to meters. Now, I need to look and see, do I have a conversion factor that relates millimeters and meters? And if I do, then this is just going to be a one-step problem. So if I look at my information here, I know that 1 meter is equal to 1,000 millimeters, okay? So that means that I only have one conversion factor that I need to use. So let's go ahead and do this setup. So identify my given and find. I'm given this value in millimeters, and I want to find it in meters. And then write the given first as a fraction. So I'm going to take this, I'm going to write it as a fraction. So 3.751 times 10 to the 5 millimeters. And to write it as a fraction, I just put it over 1. Now it says set up the conversion factors as fractions, placing the conversion so that the units you don't want or that you want to get rid of are opposite sides and will cancel. So what do I mean by that? So I know I'm going to multiply this, my given fraction, by my conversion factor fraction. This information is going to come from this relationship. Okay? Now notice that I have millimeters. I want to get rid of millimeters and convert it to meters. In order to cancel out millimeters, in this second fraction, the millimeters need to be in the opposite position. So if millimeters are in the numerator in the first fraction, they need to be in the denominator of the second fraction. So looking at this relationship, what part of this equation has millimeters? It's that 1,000 millimeters. So that chunk of that equation is going to go on the bottom. And then what goes on top will be the 1 meter. All right, so now this will allow me to sort of work it out and cancel. Now, before I do, you'll notice that this one is, my given is in scientific notation. So remember 1,000, I can put that in scientific notation as well. I'm just going to write it underneath just so we can see it. It's 1 times 10 to the 3rd. So now let's go ahead and do the math, all right? So I am going to multiply these fractions. Remember, when you're multiplying fractions, you multiply straight across. So I'm going to have 3.751 times 10 to the 5 times 1 in the numerator here. So that's just going to be 3.751 times 10 to the 5. And the denominator here, I'm going to have 1 times 1,000, or 1 times 10 to the 3. Okay? And remember, when you're dividing things in scientific notation, you divide the coefficients first. So 3.751 divided by 1 is just 3.75. 751, I should say. And then you divide the powers, that's 10 to the 5th divided by 10 to the 3rd. And when you divide powers, what you're going to do is subtract the exponents. So 10 to the 5th divided by 10 to the 3rd is going to be 10 to the 2nd, because 5 minus 3 is 2. Okay? So now I've done everything that I needed to do, and let's just check out, make sure our units are correct. I wanted to go from millimeters to meters. Notice that the millimeters will cancel out because they're opposite. And then what I have left is meters. Okay, so let's take a look at our second example here. So we will first read the problem. How much does 82.11 kilograms weigh in centigrams? All right, so in this case, I want to go from kilograms to centigrams. And although these examples here, these conversion factors are for meters, you can easily replace the meters with grams. It's going to do the same thing. So I want to go from kilograms to centigrams. I don't see a relationship between kilo and centi, right? But there is a relationship between kilograms and grams. I'm just replacing the meters with grams here. And there's also a relationship between grams and centi, right? So what I can do then is I can simply, I will need to do sort of two conversions, one from kilograms to grams and one from grams to centigrams. So my first step is always to take my second step is always to take my given and put it over 1 to make it a fraction. So 82.11 kilograms, and I'm going to put that over 1. My second fraction is going to come from the conversion factor that converts kilograms to grams. So that's going to be this relationship here. 1 kilogram is equal to 1,000 grams. Now, again, remember I'm replacing the meters with grams in my mind. Okay, so I want to get rid of kilograms. That means that this chunk of the equation, that 1 kilogram, needs to go on the bottom. They need to be opposite to cancel. And then this chunk, that 1,000 grams, needs to be on top. Okay? So now my kilograms have canceled out. And I have grams right now. But I'm not done because I want to get centigrams, not grams. So I need to do another conversion factor. All right, so now this conversion factor, I want to get rid of grams and convert it to centigrams. So now I'm going to look at the information for centi. So 1 gram is equal to 100 centigrams. All right, so that means that since in this case now I want to do is cancel out the grams, I need to have the 1 gram go on the bottom and the 100 centigrams to go on top. Okay, and so now I have my units that I do want left. I have centigrams left and every other unit canceled out. Okay, so now all I need to do is just multiply some fractions. So in my numerator, I'm going to have 82.11 times 1,000 times 100. And that's going to give me this huge number. It's 8,211,000 centigrams. Okay. And the denominator here, I just have 1 times 1 times 1. So this number divided by 1 is my final answer. Now, if I wanted to, I could, so this is my final answer. So if I wanted to also, I could write this in scientific notation. Either answer is acceptable, so 8.21 times 10 to the 6 centigrams. And the way that scientific notation works is your coefficient needs to be in the ones place, and then the rest of it, I'm just going to count up how many places that is. 1, 2, 3, 4, 5, 6. So that's 10 to the 6. All right, so either answer works. Let's do our next example. And our next example It says that the pressure inside a gas tank is 547 millimeters mercury. What is the pressure in pascals? Now in this example, I'm not using prefixes to convert to and from things. What I am using is sort of another conversion, all right? And I have some other conversions here. So for pressure can be, there's different uses for pressure. 1 atmosphere is equivalent to 700 millimeters mercury of pressure. So this is one conversion. And another is 1 atmosphere is equal to 101,325 pascals. So in this example, I'm converting from millimeter mercury to pascals, but I don't see an equation that relates millimeter mercury and pascals. You don't see an equation with both millimeter mercury and pascals in it. But I have one that relates millimeter mercury to atmosphere and atmosphere to pascals. So that's going to be my plan. I'm going to go from millimeter mercury to atmosphere and then from atmospheres to pascals. So let's start by taking our given 547 millimeter mercury. And again, I put it over 1 just to make it a fraction. Second fraction, it'll be my first conversion factor to go from millimeter mercury to atmosphere. All right, here's the equation that relates it. I know it's the equation that relates it because it both has atmosphere and millimeter mercury in it. All right, what part of this equation goes on the top? What part goes on the bottom? Well, I want to cancel out millimeter mercury, so the 760 millimeter mercury must go on the bottom. It needs to be opposite to cancel those units. And then the 1 atmosphere goes on top. Okay, canceled out. The second fraction is going to come from the conversion of atmosphere to pascals. In this case now, I have atmospheres left. I want to get rid of that and convert it to pascals. So the 1 atmosphere in this relationship is going to go, or my conversion factor is going to go on the bottom, and then the 101,325 pascals goes on top. All right, you see my atmospheres cancel out. All right, so now I have my work done. So what I need to do now is go ahead and do the math for this. And for the math, I'm going to multiply what's in the numerators together first. So 547 times 1 times 101,325. 547 times 1 times 101,325. So multiplying all those numbers together, I get this huge number, 554,24775. And the denominator, I'm going to have 1 times 760 times 1, which is just 760. All right, so now what I need to do is just divide these two numbers. And I get this number here, 72927. Actually, it goes on a little bit. There's some decimals there as well, and that's pascals. Now, let's go ahead and take a look at using this, using some significant figures. Using some significant figures here. In this example, I started off with 3 significant figures. Now, when you're doing unit conversions, if the conversions are exact conversion, like 1 atmosphere is exactly equal to 700 millimeters mercury, you ignore these for your significant figures. So the only thing I'm going to focus on in terms of counting the least number of significant figures is the value that I started with. If this is in 3 sig figs, then my final answer needs to be in 3 sig figs. So I'm going to go 1, 2, 3. My cutoff line will be the 9 and the 2. And then I get 7, 2, 9. And then this will just be 0, 0 pascals. So 72,900 pascals. And that's my final answer. All right, last thing. We're converting from mercury freeze at 38 degrees Celsius. What is temperature in Kelvin? In this case, we're not going to use dimensional analysis because this is not a scalar relationship, but it's simply just some algebra. So I have Kelvin is equal to degrees Celsius plus 273. I have my degrees Celsius, that's 38. I'm going to plug that in where I see the degrees Celsius. Okay, sorry, I'm just going to move that down. Okay, so there it goes. So where I said degrees Celsius, I'm going to put 38 and then plus 273, and that's equal to Kelvin. All right, so all I need to do to convert this, just add these together, 38 plus 273. And I get 311. So my Kelvin temperature is going to be 311 Kelvin. All right, and that's all we have to do here. All right, I hope you found this video helpful on using dimensional analysis. If you have any questions, please let me know. Have a quality day.